Hello everyone, my name is Kyla Zimplinsky and I am your Darlington County 4-H Extension Agent. Today I'm going to be showing you guys how to do the exciting experiment called Soybean Plastic. This goes along with the book that I read to you guys in an earlier video, Annie Yang's Great Soybean Picnic. Your teacher should have provided you the laboratory worksheet, which contains the materials and how to do the experiment. What you'll need to do the experiment include, obviously, the laboratory worksheet. You will also need cornstarch. You'll need vegetable oil. Any vegetable oil works just fine. You will need a sandwich size Ziploc reusable plastic bag. Food coloring, any color works great. Today I am using blue food coloring. You will need a microwave, water, a pipette or eyedropper. If you do not have a pipette or water or eyedropper, a spoon, a little one such as this works just fine. Or if your measuring spoons have a 1/8 tisp like this, that works fine as well. You'll need a kitchen scale, like so, a little one like this. You can get this at any grocery store like Walmart. And then you'll need your laboratory worksheet, and then you'll need your Property of Manners PowerPoint, which comes with your laboratory worksheet. So what we are going to do is we are going to first add 1 tablespoon of cornstarch to our sandwich bag, which I have already done. And then we're going to add 2 drops of our soybean oil. Now, if you're doing this at home, do this in your kitchen, and anytime you're measuring things, do it either over your garbage can or your kitchen sink, so it just makes cleanup a little bit easier. Okay, so I'm going to measure out my oil. Like I said, any vegetable oil works just fine. And then always make sure you recap everything so you don't accidentally knock some over and it spills everywhere. So here's my oil. Then we need 1 tablespoon of water. Right, and then what you're going to do is you're going to close the bag and make sure you get all the air. Do this either in your kitchen sink or above a garbage can, so in case you spill, makes cleanup a little bit easier. Seal the bag, and then I'm going to knead the contents with my fingers, mixing them. Make sure when you're kneading, you're not being really forceful. You don't want to accidentally burst your bag open. Okay. Then I'm going to add my 2 drops of food coloring. So like I said, I'm using blue. You can use any color, red, yellow, pink, green, whatever floats your boat. Okay, so there are my 2 drops of food coloring. Okay, seal the bag again. And then mix. So see, now it's blue. Right, so there are some questions on your lab sheet that you need to answer before we go on to the next step. One is, so what we're going to do is I'm going to open the bag just ever so slightly so it can vent. So just a little hole, you don't need a big one. And I'm going to weigh my bag using my little kitchen scale. Okay. So according to my little kitchen scale, my bag is about 26.5 grams. And I'm going to write that down. You want to do this before you microwave. Okay. So another question is, you want to describe the mixture in your plastic bag. Remember, do all these before you microwave. So it's mine kind of looks like this bluish. It's like, describe the color. It's light blue. Obviously not solid, hasn't coagulated, which means a liquid coming together to form a solid, kind of like when your blood coagulates. How does it feel when you squish the bag? I'm not the best at describing this. Feels mushy. So is your mixture a solid or a liquid? It's a liquid. Mushy. Maybe mushy is not the best way. Runny. Okay, so the next thing you're going to do is you're going to microwave your bag. So remember, you don't want to have the bag sealed all the way. It needs to vent. So just take a corner and open it slightly like I did here. And then you're going to put it in your microwave for about 20 to 25 seconds. You want to leave a part of the bag unsealed so the contents can vent and some steam can escape. So I'm going to microwave mine for 20 seconds. Okay. Now, after it's done being microwaved, you want to make sure that you want to remove it from the microwave and let the plastic cool, because the bag and the contents itself will be very hot. You want to be very careful. All right. So I'm just going to let it sit for a few more seconds. Like I said, it's very hot. So this is where you probably want, obviously your parent should be here, parent or legal guardian should be here to supervise you, but I recommend that when you get to this stage, let them take the bag out. Wear oven mitts if you so wish, use a towel or something to protect your fingers from getting burnt. All right. So we'll let that cool for a little bit because we're going to be touching it and I don't want to burn my fingertips. So still very hot, but you can go ahead and answer part 2 of the questions. First question is, what does your substance look like now? So I'm not going to touch it. So to me right now, it looks a little bit like gelatin, like Jell-O. Looks like Jell-O. I'm going to write that down. Okay. How many grams? So you're going to weigh this again. Make sure your scale is zeroed out and you're using the same units. In this case, I used grams. So it's zeroed out. So right now mine weighs about 25.5 grams. So is the weight the same as before? No. Why or why not? I'm going to say because it's no longer a liquid, it's more solid. because more solid like. Okay. So it didn't really, statistically, the weight really didn't change much. Difference between, 1 gram in weight statistically really isn't significant. So regardless of the type, so basically what happened was we had you want to compare the weight of the measurements before and after you microwave. And using your property of matter PowerPoints, this discusses your changes in your physical and chemical changes. So you want to ask yourself, is soybean plastic a physical or chemical change? Let's go to the PowerPoint. So a physical change is a change that does not change the identity of the substance. So melting ice, it's still water when it melts. Boiling pasta, it's still pasta. Tearing paper, if I tear this, it's still paper. Chopping wood, I chop wood, it's still wood. A chemical change changes the identity of a substance. So burning wood, you burn wood, it's no longer wood, it's charcoal, it's ash. Digesting food, you eat food, comes out the other end, it's no longer what you ate. Baking a cake, it goes from being a liquid to a solid. Cooking an egg goes from that liquid gelatin-like to a little bit more of a solid, okay? So what you did now, because it changed from a liquid to more solid-like, it's now, that's still hot. Like I said, it's still, so if I took this out of the bag, I'm not going to because it's still very HOT. This is very solid-like. It's kind of like Play-Doh or silly putty. If you don't know what silly putty is, ask your parents. It's an old school toy. Oh. Okay. So what we did was a chemical change. So basically, regardless of the type of change that occurred when heating, cooling, or combining substances, the total weight of the matter is conserved. So your bioplastic in this case should weigh very close to the starting weight before it was heated. In this case, we only lost 1 gram, as I mentioned. The difference between 1 gram statistically isn't significant, okay? So you want to ask yourself, wrap this up, what objects can be made with bioplastics? Bioplastics, if you're wondering, bioplastic comes from a living thing. 2 common bioplastics are corn plastic and soybean plastic, hence the reason why we used vegetable soybean oil, okay? So you're probably wondering, what is this plastic made from? So plastics, so like a plastic water bottle like this, many plastics come from petroleum based, which is not a renewable resource from the earth, okay? So you want to ask yourself, what objects can be made from bioplastics? So stop and think about that. It's a lot more simplistic than you think. So the answer to that is disposable items such as packaging, cutlery, knives, forks, spoons, and bowls are common. Some companies have even come up with bioplastic toys. Right? So another question you might want to discuss with your parents or your teacher are how does plastic and bioplastic affect the environment? And how does bioplastic affect farmers? So think about what you hear about all the time in the news about plastic waste being washed up on the beaches, being caught in marine animals, woodland animals. Stop and think about that, what the news media says. This is what happens when we just toss our plastic all willy-nilly instead of being more considerate and recycling it. And the same thing goes with bioplastic. And then how does bioplastic affect farmers? As I mentioned, bioplastic comes from plants, so corn and soybean. Well, what other uses do we use corn and soybean for? We eat corn, we eat soybeans, we use that to feed our animals. So some worry that bioplastic industry will expand into land set aside for growing crops for human consumption. And others also agree that this will wreck on the natural ecosystems. So think about it with your parents about, bioplastics, looking on both sides of the fence, why some people are for it and why some people are against it, and try to see if you can find a middle ground, right? So once you're done, obviously, still, okay, cool down a little bit. You can properly dispose of this, or if you want to, keep it, up to you. I'm gonna just pitch mine. But, thank you guys so much for joining me on this fun soybean plastic experiment that complemented the very fun book I read to you guys earlier. I appreciate you having me, and I hope you guys have fun doing this experiment on your own.